People have always been fascinated with light and the sense of sight. But not all the ideas about light and sight have been correct. For instance, about 2,000 years ago, the Greeks thought that eyes worked because they sent out energy that hit an object and bounced back. They thought this because they observed the eyes of animals such as cats, dogs, and deer in the dark. Their eyes appeared to glow. It was this glow that made them think that the eyes were generating a light energy. Actually, cats, dogs, and deer can see better in the dark than we can because their eyes can open up further to collect as much available light as possible. However, nothing can see in total darkness because all eyes need an outside light source to work. We now know that eyes make it possible for animals and humans to see because of reflected light. This is how reflected light works. Light strikes an object and bounces off or reflects. The reflected light enters our eye, and an image of what we see is formed on the back of the eye called the retina. The retina is made up of rods and cones that are sensitive to light. The rods are sensitive to light and dark, but not color. The cones are capable of sensing different colors. Primates, including humans, are the only mammals to experience full color vision. Dogs, cats, mice, rabbits, and most mammals see a black and white world because their eyes lack color-sensing cones. There are other animals that can see color, but usually not all the colors we see. Usually animals that look colorful can see in color. For instance, birds and butterflies can see in color. Scientists have found color-sensing cones in the eyes of birds and butterflies. Even snakes and lizards can see colors. The bright colors and markings of many animals help them to identify each other. Many birds and fish have their eyes on the side of their head so that their field of vision is larger. This helps them to see things that might be approaching them from different directions. Insects have compound eyes, which are made up of thousands of lenses. This is a close-up of a bee's eye.